Dear students, in this lecture, we will discuss about the throttling process. So, throttling process is the process in which some fluid is allowed to pass through a restricted passage. So here, this process, which is called the throttling process, involves the passing of a high pressure fluid through a narrow constriction, and that results in number one, reduction in pressure and temperature, number two, increase in volume, third, increase in entropy, fourth, constant enthalpy. So if some fluid is allowed to pass through a passage which is restricted or a narrow passage like a porous plug, etc., there are some important characteristics of the throttling process is that the enthalpy remains constant in this process. Additionally, the throttling process is an adiabatic process. It means no heat flow from or to the system, but this process is not reversible. It is definitely an irreversible process. We can take the example of this process as steam stop valve, throttle valve, which are installed at the entry of the steam turbine in power plants. When flow of steam takes place through these valves, throttling process occurs. So here we can take one example of a porous plug. You can see here, this is a porous plug, and through this porous plug, the fluid will be allowed to pass through it. At one section, the some fluid is entering from this side and passing through this porous plug, it will leave from this exit side. There may be another passage in which it may be of the shape of a nozzle, where the area from this inlet is going to be decreased. So this is also a restriction of the passage. Now, particularly in case of the steam, when it is allowed to pass through restricted passage, because it is having its application to find out the dryness fraction or quality of the steam. So when the wet steam is allowed to pass through restricted passage, the wet steam is converted to the superheated steam, and then this process is useful to find the dryness fraction. So if we take the wet steam as the fluid which is allowed to pass through a restricted passage, then this can be done by representing it on HS diagram. So here, this is the HS diagram in which on the vertical axis we are showing the enthalpy, and on the horizontal axis we are showing the entropy. And this line indicates the dry saturated vapor line. This is called as the dry saturated vapor line. Now, there are the two curves. One is here showing the pressure P1 and another is showing the pressure P2. So definitely when the steam will pass through a restricted passage, the pressure will go on decreasing. Here, the point 1 indicates the condition of the steam at the inlet, or we can say at the entry side. And point 2 indicate the exit condition of the steam, or maybe of the any fluid. So here, what changes occur between point 1 and 2? Because in this process, enthalpy remains constant. So enthalpy at point 1 and 2 will be same. So here H1 will be equal to H2. When the fluid will pass through the restricted passage, there will be pressure drop. So P1 is greater than P2. Also, there is the temperature drop. Temperature will also decrease slightly. So T1 here is greater than T2. But when the fluid will pass through this restricted passage, it will result in increase of entropy. So here S2 is greater than S1. It means entropy will increase. So because at point 1, it is showing the condition of the wet steam. At point 1, the steam is the wet steam. And at point 2, the wet steam is converted to the superheated steam. Because in this process, enthalpy remains constant. So we can equate the enthalpy at the inlet as well as at the outlet or the exit. So for the constant enthalpy, H1 and H2 both will be same. Because H1 is the enthalpy at point 1, and at point 1, because this is under the dry saturated vapor line. So one indicates the condition of the steam, which is the wet steam. For the wet steam, we can write enthalpy H1 equal to HF1 plus X1 into HFG or HFG1. At point 2, the enthalpy will be, because at point 2, it is the condition of the steam, which is the superheated steam. So H point 2, we can write enthalpy H2 equal to Hg2 plus Cp T super 2 minus T saturated 2. So these enthalpies can be written at point 1 and at point 2, because in this process enthalpy remains constant. So we can equate these two enthalpies, means H1 is equal to H2. By equating, we can write in this way: HF1 plus X1 HFG1 equal to Hg2 plus Cp T super 2 minus T saturated 2. And by equating this, we can write in this form: X1 is equal to Hg2 plus Cp T super 2 minus T saturated 2 minus HF1 whole divided by HFG1. So by this formula, we can find the X1, or that is the dryness fraction of steam. So this process is used in case of a calorimeter, which is called as a throttling calorimeter. In the throttling calorimeter, the throttling process is used to find the dryness fraction of steam. Okay, so in this way, we understood what is the throttling process, what are its applications, and which properties changes. Which property are changes means pressure decreases, temperature decreases, entropy increases, but enthalpy remains constant. Thank you.